Here we have this theorem. Let A, B, C, and D be four sets. Then we have the following. The Cartesian product of A and the set B intersection C is the same as the intersection between the Cartesian product of A and B and the Cartesian product of A and C. So A cross B intersects C is the same as A cross B, then intersects A cross C. So again, here we need to prove two sets are equal, right? So as we always do, we prove the first set, the left hand side is a subset of the right hand side, and vice versa. So let's prove this part first. We prove the first containment. So A cross B intersects C is a subset of A cross B intersect A cross C. So set A is a subset of set B if any element in A is an element in B. Right? So now pick an arbitrary element, say, because this is a Cartesian product, so I can just write it as x comma y as an element, arbitrary element of this set, right? Because this is a Cartesian product. So Cartesian product is a set of all ordered pairs x comma y, right? X in A, y in the other set B intersects C. We want to show that x comma y is an element in here. Okay. So now let's look at our hypothesis. X comma y is element in A cross B intersects C. What does that mean? So by definition of Cartesian product, we have X is an element of A and Y is an element of B intersects C. Okay, let it be there first. X is in A, Y in B intersects C. This means that Y is an element in B and Y is also an element in C. So by definition, Y in B intersects C means Y is in B and Y is in C. So now we have this. X in A, Y in B. What does that mean? By definition, we then have X comma Y is an element in A cross B. Does that make sense to you? X is an element of A, Y is an element of B, and therefore X comma Y is an element of the Cartesian product of A and B. By definition of Cartesian product. Alright. Similarly, we also have this. X in A, Y in C. Therefore, X comma Y is an element of A cross C. Now we have, since X is in A and Y in C, we have X comma Y is in A cross C. So we have X comma Y in A cross C. We have X comma Y in A cross B. Therefore, X comma Y must be an element in the intersection of the two sets. Therefore, X comma Y must be in the intersection of A cross B intersect A cross C. And you see, this is exactly what we need to show. This is exactly what we need to show. Therefore, we have the first containment. So we already show this part. So we have the first containment, and now we prove the other way around. To show this set is a subset of the other one. Is a subset of the other one. Okay, similar as we did before, this is a set, this is another set. So we pick an arbitrary element in this set. So as we talked before, we know that this is an intersection of two Cartesian product, right? And the element in the Cartesian product is ordered pairs. The set of unordered pairs x comma y, x in A and x in B. So arbitrary element here must be of the form x comma y. So let me pick, let x comma y be an arbitrary element in the left hand side. This set we will show that x comma y is an element of A cross B intersect C. Okay. So let's look at the hypothesis. X comma y in A cross B intersect A cross C. By definition of the intersection, we have x comma y must belong to both sets A cross B and x comma y be an element of A cross C. Now we have, since x comma y is in A cross B, we know that x must be in A and y is in B. And similarly, we can do the same thing, but for the other Cartesian. So similarly, we can do it for, so this we do it for the first set, and now we do it for the other one, A cross C. A cross C. So x in A, but y is now in C. Okay. Y in C for the first one, and y is in B for the. So we have y is an element in B here. Y is an element in C here. Therefore, y must be an element in B intersect C, right? Y must be an element in B intersect C. And we also have x in A and x in A. Therefore, by definition of Cartesian products, the ordered pairs x comma y is in A cross B intersect C. Does this make sense? The first one in the ordered pairs belong to A. The first one in the ordered pair belong to A. The second one in the ordered pair belong to B intersect C. So this means that this ordered pair x comma y must be an element in A cross B intersect C, which is exactly what we need to show. And therefore we prove this part. and which is the second containment we need to show, right? Hence we show that the two sets are equal. So we finish the proof of this statement, of this theorem. Okay, so this is how we prove it for Cartesian products.